This day 26 learning in this machine learning playlist, we are going to be looking at early stopping, logistic regression, softmax regression. Right? These are few new topics, and these are the few set of remaining topics in training a model. So we have looked at many different concepts like starting out with linear regression, a basic linear regression model, and next we have also looked at gradient descent, polynomial regression, learning curves, and ridge lasso and elastic net to optimize or improve the generalization factor by reducing the error. Early stopping is also a continuation to the previous ones. So we are going to be starting off with early. We are going to be starting off with early stopping. So let's start. So early stopping. So let's say in order for us to understand early stopping, so we know that many times when we train a model, we will always have, or we will most of the times have, training error 0 and validations error 0 in the first or um, initially trained model. Once we have a model trained and we start introducing external batches of validation dataset or external datasets, we start to see validation error going up. Even though we train this new dataset, sometimes we might introduce unlikely data points or um, some sort of outlier data points, which might also cause this. But yeah, that might be a reason. But overfitting is also a pattern that is observed when we start looking at more data sets that we test out our model with. So that's when we want to take an action, having to stop early instead of having to accept a lot more data. We keep our model sanitized and clean and not take the other data which hampers the or increases the validation error. Right? So I have a simple polynomial regression model, and also I have a HDD regression model and a simple piece of code snippet here where I have created a small piece of Python code. It is nothing complicated again. So using these 500 epochs as a batch of datasets to train the model and test the and see the train and validation errors. So we are appending all the train and validation errors, thereby having to display the best epoch and the best validation mean squared error. So this is what we are doing here. We are iterating to each batches and seeing if the model increases in validation error or not. So after, if you see, there is early stopping at 28th epoch and best epoch was at 8 with a validation score of 12 or 13. Right? So as you could see, so 12 is somewhere around here, and after 23 we could see the spike in validation and train error. So that's the key takeaway with early stopping. So yeah, now that we have understood early stopping, let's look at logistic regression. So we have looked at linear regression, which has a uh, formula something like this, or a formula something like this. So with this formula, logistic regression converts it to a sigmoid function something like this, which returns a value between 0 and 1. These are um, probability values which can help in classifying as well. So these are probability like values which can also help in classification. Sigmoid function's response looks like this. So the zeroth ground point is zero point 0.5 and it goes this way and this way. So that's one thing. And next is we have a logistic regression cost function. Let's say we have a small training example like this. So we start a true class between 0 and 1. We have two classes, 0 and 1. Predicted probability is 0. So it would be, if it is 1, it would be of 0.9, very small cost, minus 0.1. So with this function that we see, right? So there might be many different functions. We are taking a very idealistic function with the log based approach, and we see that 0 0.5 is a large cost or a median point. This is how those two classes could be represented with logistic regression model, right? So logistic regression, in a simplest way, there are two classes which can be clearly or probabilistically classified. A probability value can classify that. Next is training logical regression with scikit-learn. So we are doing a small iris dataset, taking a small iris dataset where we would be given with petal length and petal width as a deciding factor to decide if it's an iris sentosa category or not. So that's where we are using this logistic regression as an example problem, right? So this is also a project. Iris is a flower, and it's a purple kind of a flower you can discover in online, and you could see more on iris dataset, right? So here in this dataset we get about petal length and petal width, which are the key features to decide if it's of iris sentosa family or not. So we said that logistic regression has probabilistic prediction. So difference between probabilities, it gives us values. Prediction is like we need to find a specific class or not, whether it belongs to a iris family or not. So that's the key point. Next is logistic regression decision boundaries. Like we saw here, we have boundaries, say something around this. So there might be chances that one might overlap on these two. So there might be certain median points where it is clearly not differentiable between two classes in case of logistic regression. That's where these points are, right? So hope these points. So I've also added this chart here, just showcase how boundaries would look like, right? So more than this, it might be of a class 0 and class 1. So that's one thing. Next is softmax regression. Continuing with logistic regression, softmax regression helps in multi-class classification. So that's one thing, and it has a formula again, something like this, which can give us a soft up and down kind of a curve, smooth wavy kind of a curve, and it has a cost function which can help us decide if specific classes belong to one or not. So that's about softmax function, which so consider the same iris dataset. We can differentiate. There are few different classifications in iris dataset which can be classified like Sentosa, versicolor, and virginica. If you see, versicolor and virginica are very close, but yeah, they can be classified with softmax regression based on the probability values. So these were all the learning items that we have for today. So, and I have also added few learnings with last few lessons. I will attach this IPython notebook. Hope you found this video helpful. Thank you.